Section 4.3, the maximum and minima, problem number 4. It tells us to find the critical numbers of the function f of x equals 12x to the 5th minus 45x to the 4th minus 20 times x to the 3rd minus 8, and classify them using a graph. So the first thing we do is we find the derivative of this function. So f prime of x equals 60 times x to the 4th power minus 180 times x to the 3rd power minus 60 times x to the 2nd power. And when we're so the next step we do is we factor out the 60 x to the 2nd power, and once we do that, we also get in parentheses x squared minus 3x minus 1, and then when we find, and then we set them all equal to 0, so 60 times x squared equals 0, we get our x value equals 0, and then for the other part, since this one is not factorable, we're going to need to use the quadratic formula, which is over here. So we plugged it in, and we get two values due to a square root. So we have x equals 3.303 and negative 0.303. So what does these three x values means? Well, they're the critical points on the function, the original function, where like if you plug in these x values, and you get a y value, and the tangent line at that point, the slope is going to be 0. That's what it means. So now that we have our critical points, our three critical points, we can just like set like a number line for these 3 points, and then we're gonna plug in like some numbers in between these intervals and stuff, and the way we do that is like, let's say like I use -4 here, and we're gonna plug the -4 into the derivative function, which is 60 times x to the 4th minus 180 times x to the 3rd minus 60 times x to the 2nd, and then we'll get a value. So I got basically a positive value where the f prime -4 is a negative value here at where it's like negative 0.1, and another negative value at where 0.1, and then again a positive value where f prime is 4. So since moving from reading the graph from left to right, our slope goes up and then down, and it goes down again because these two negatives are next to each other, and then it goes up. So here we have these parabolas where I labeled the max and the min. So this is what it will look like on the graph in between the critical points when we graph the original function. So where we classify this on a graph, and I've already done the values at the critical point. So here's the graph. It's not drawn perfectly to scale though. Basically, if we verify it again, so going from left to right, we have our, we go here, it's going up, and then down again, and then it goes up again. And then looking at our values, where for the original function, where x equals 0 is neither max or min, where x is 3.303, we have a local minimum, and where x equals negative 0.303, we have a local maximum. And that's it.